about the Monsanto acetic acid process. It is the method of a conversion of methanol into acetic acid. It is the reaction with a carbon monoxide, or simply the production of a acetic acid by the carbonylation of a methanol. Methanol is carbonylated to acid, CH3OH plus CO giving CH3COOH. And we have seen that the catalyst used Monsanto acetic acid process, and the catalyst used is the rhodium catalyst, which is the square planar D8 16 electron species of rhodium one. Okay, the rhodium 1 is 16 electron species. Rhodium 1 is how many electrons in rhodium 1? It is 8 electrons. 8 plus 8 16 electron species is there. Okay, this is a starting compound, and you can see that the catalytic cycle, the catalytic cycle is consisting of only 4 species. 4 species cycle. Very simple. The first one is the addition of a methyl iodide, or we can see that is the oxidative addition reaction. This methyl iodide is formed from one of the reactant species, that is CH3OH, and you can see that HI starting compound CH3OH methanol, and HI comes from some stage that will be clear later, and we can see that these two react to form methyl iodide, very simple, nitrogen plus HI giving CH. So you can see that water will be eliminated in this CH3OH plus HI giving CH3I plus H2O. H2 will go out, and this CH3I will combine with the catalytic species, and oxidative addition reaction will take place, and the product formed will be a 8 coordinate complex. See, we can see that all these species remain there, and the methyl iodide is added like this. So now this is a rhodium 3 complex. Then you can see that there is a 18 electron species. Rhodium 1 16 electron species, rhodium 3 18 electron species. Okay, now next stage. Mistake is the migratory insertion reaction. Migratory insertion reaction, that is the reaction between these two, that is a COCH3, carbonyl insertion or methyl migration. That is called a migratory insertion, and you can see that the product formed is a very simple to draw. And you can see that COCH3. That is CH3 is converted into COCH3. This position becomes vacant, and you can see that the other carbon monoxide is here, and the 3 iodides remain in their position. Okay. Now we can see that this is again a rhodium 3 complex. Rhodium 3 complex means it is a 7 plus 7 plus 10. 17 plus 1, 18 electron species. Okay. Now the next reaction is a the addition of carbon monoxide, that is the second reactant. The reactant the carbon monoxide gets coordinated to the site that is created by the migratory insertion carbon monoxide vacancy. And we can see that RH will get one CO here, second CO is there, and we have one iodide, second iodide, the third iodide, and one COCH3. Okay. We can see that this vacant position is occupied by the newly added carbon monoxide. And the next step is the reductive elimination. And the reductive elimination, we can see that the two species that undergoes combination will be CH3CO and I cis2, this one. Adithilla cis sitella or iodide good CH3COI, that is the species that is eliminated, CH3COI. So you can see that here the reductive elimination takes place, and the CH3COI once removed is converted into RH, CO twice, I twice, that is this one. So this is the cis coordinate complex species eliminate CO, that is the negative charge negative charge. That's all circular negative charge. Okay. Negative ions C3I neutral molecule, but the insertion but the CO neutral molecule, put the neutral molecule, and a charge throughout -1 charge. Okay. This C3COI gets converted into CH3COOH, that is the product. How? By the reaction with the water. And we can see that CH3COI, when react with water, what is the product formed? CH3COOH and HI. That HI is this HI. See, this is starting compound CH3OH. I have first said that it reacts with HI. This HI, where does this HI come from? This HI comes from the reaction of the final product, that is acetyl iodide. See, in the migratory insertion, in the reductive elimination step, the product formed is actually not acetic acid, but acetyl chloride or acetyl iodide. And this acetyl iodide reacts with water. And where does water come from? Water comes from the reaction between the acetic acid and HI. And where does HI comes from? HI comes from the reaction between acetyl iodide and water. You can see that this water is used up here, HI is used, water is produced. For what HI is used? HI is used for the reaction between methanol to form methyl iodide. And the byproduct in that is water. And that water is used for converting the final product, that is acetyl iodide into acetic acid. When acetyl iodide is converted to acetic acid by reaction with the water, we can see that HI is again produced, that HI is used again. So we can see that the reactant products are here, methanol and CO. These two are the reactant species, and we can see that there is only one product, that is acetic acid. So you can see that CH3OH plus CO giving CH3COOH. Is it clear? The first compound, this is a 4 coordinate complex, this is a 6 coordinate complex, this is a 5 and it is converted to 6 again. You can see that this is a 16 electron species. That is a rhodium 1. This is rhodium 1. Catalytic cycle representative, this is a 16 electron species and rhodium is rhodium 1. and here it becomes a rhodium 3 species. In the rhodium 3 in the one negative negative CO is neutral, methyl is -1, -2, -3, -4, and rhodium is +3, so means a net charge is a -1. And we can see rhodium 3 is a rhodium 1 is 8, rhodium 3 is a 6 electron species. 6 plus 12, that comes an 18 electron species. Okay. And by migratory insertion, we can see the oxidation state of this one does not change. That is not an oxidation, not a reduction. No, it's only a migration of CO. And we can see that a negative, 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 4 negatives are there, and 1 negative, so that it's a rhodium 3 complex. Rhodium 3 complex has how many electrons? 6 electrons only, and 6 plus 10, we can see that this is converted again into a 16 electron species. Rhodium 3 rhodium is coming under cobalt, and it is absolute configuration, electronic configuration is D7s2, 9 electrons. So it is rhodium 1, it has 8 electrons, and this rhodium 3, it has only 6 electrons. And from this 6 in the body, there are only 5 ligands. 5 ligands contributed 10 electrons, and 10 plus 6 a 16 electron species. And you can see when it comes here, it is again a rhodium 3 complex, but it is a see the rhodium carbon monoxide 2 electron would go to 3 rhodium 3I, that is 18 electron species. Good with the 16 electron species. You can see that the alternates between 16, 18, 16, and again 18. Okay. And it is rhodium 1, rhodium 3, and rhodium 3, and also it is converted again into rhodium 1. Okay. We can see that the starting compound is actually not methanol. Starting compound reactant, but methanol is first converted into methyl iodide. By reaction with HI will be produced, you can see at the end. When the cycle starts running, we can see that the process goes smooth. This HI converts methanol into methyl iodide, and methyl iodide involves in a oxidative addition reaction with the catalytic species, this one, forming a cis-coordinate 18 electron species, which immediately undergoes a migratory insertion between this methyl and CO, forming COCH3, creating one vacancy. If methyl ligand acetyl ligand is contributing the same number of electrons. So it is a loss of 2 electrons, that means 18 is converted again into 16. And the vacancy created by the migration of CO, migration of methyl, you can say, immediately is filled by the coordination of the carbon monoxide, which is the other reactant, due to the array. And we can see the product formed undergoes reductive elimination, and the reductive elimination results in the formation of 2 species. One is the original reactant or original catalytic species, other one is the product acetyl iodide. Acetyl iodide is hydrolyzed into acetic acid, and during this process HI is produced. Okay. This is the catalytic cycle involving the Monsanto acetic acid process. Okay. And one more point, we can see that here this is the rate determining step, that is the migratory insertion step. Okay, and importance of the so you can see that this rhodium based catalyst for this Monsanto process was originally developed by the German company BASF, and it was later taken up by the Monsanto company. And of course, later you have seen that instead of rhodium, if iridium catalyst is used, the process becomes somewhat more economic. And this catalyst was actually developed by another company, that is again a well-known company, that is a British company, BP Chemicals Limited, British Petroleum. So we can see that the BP company, British company, introduced a new reagent, that is a new catalyst, that is the iridium-based catalyst, which has the same structure, no difference at all. That is, instead of rhodium, we have iridium, that is all. But a slight difference is that this is promoted by a little ruthenium. Ruthenium promoted catalyst. That the promoter line, the catalyst and promoter. Promoter promotes the activity of the catalyst. And it is ruthenium promoter ഉപയോഗിച്ചുകൊണ്ട് നമ്മുടെ Monsanto process ഉപയോഗിച്ച് അതേ catalyst വ്യത്യാസം എന്താണ്? Rhodium is substituted by iridium. Iridium comes cobalt, rhodium. അതേ ഗ്രൂപ്പിൽ വരുന്ന യാതൊരു വ്യത്യാസമില്ല. അപ്പോൾ സ്വാഭാവികമായിട്ടും ഒരേ പ്രോപ്പർട്ടി കാണിക്കും. ഇത് BP Chemicals ഉള്ള കമ്പനിയാണ് ഇൻട്രൊഡ്യൂസ് ചെയ്തിരിക്കുന്നത്. Okay, and this process, Monsanto process പറയാൻ പറ്റില്ല, അതിന്റെ പേരാണ് അടുത്ത നമുക്ക് പഠിക്കാനുള്ള മെത്തേഡാണ്, that is called the Cativa process. Cativa എന്നോ Cativa എന്നോ നമുക്ക് എങ്ങനെയും പറയാൻ കുഴപ്പമില്ല. Cativa, Cativa process or Cativa process, whatever it may be. So what is the difference between it is? Again, remember that Monsanto process is for the manufacture of a acetic acid. This process also is for the same, that is a manufacture of a acetic acid. Okay, then what's the difference? The difference is that instead of rhodium we use a iridium as the catalyst, but iridium catalyst should be promoted with a little ruthenium. Then value lavamund, you can see that rhodium is very costly, and you can see that iridium has cost almost 1/10 of that of rhodium. Rhodium 10 വില മാത്രമേ ഇറിഡിയത്തിനുള്ളൂ. ഇക്കണോമിക്കലിയും വളരെ ലാഭമാണ് ഇറിഡിയം ഉപയോഗിച്ചതിന്. വേറെ ലാഭങ്ങൾ നമ്മൾ ചെയ്തതിനെ കാണാം. And we look into the catalytic cycle involved. ചെറിയ വ്യത്യാസമാണ്, very slight difference ഉണ്ട് എന്താണെന്ന് നമുക്ക് മനസ്സിലാക്കാം. So if you represent the catalytic cycle involving the new catalyst or the Cativa process, you can see that it is an iridium-based catalyst. ഇതൊന്ന് മാറിപ്പോയിരുന്നു കേട്ടോ, ശ്രദ്ധിക്കുക. മറ്റേത് റോഡിയം ബേസ്ഡ്, എപ്പോഴും ശ്രദ്ധിക്കേണ്ടത് നമ്മളെ പീരിയോഡ് ടേബിളിൽ അത് ഓർത്ത് വെച്ചൊന്നും മാറിപ്പോയില്ല. അയൺ, കൊബാൾട്ട്, ഇവിടെ എപ്പോഴും വായിക്കില്ല. റുത്തീനിയം, റോഡിയം, പലേഡിയം, ഓസ്മിയം, ഇറിഡിയം, പ്ലാറ്റിനം. മനസ്സിലായില്ലേ? അയണിന്റെ താഴെ വരുന്ന സാധനം റുത്തീനിയാണ്, അതിന്റെ താഴെ വരുന്നത് ഓസ്മിയാണ്. ഇവിടെ കൊബാൾട്ടിന്റെ താഴെ വരുന്നത് റോഡിയാണ്, റോഡിയത്തിന്റെ താഴെ വരുന്നത് ഇറിഡിയമാണ്. നിക്കലിന്റെ താഴെ വരുന്ന പലേഡിയാണ്, അതിന്റെ താഴെ വരുന്നത് പ്ലാറ്റിനാണ്. അപ്പോൾ ഇലക്ട്രോൺ എണ്ണം, ഇലക്ട്രോൺ ഒക്കെ പെട്ടെന്ന് ഇറിഡിയം കണ്ടാൽ വേറാണ് ഇറിഡിയം കൊബാൾട്ടിന് കീഴിൽ. കൊബാൾട്ടിന് ഇലക്ട്രോണിക് കോൺഫിഗറേഷൻ നമുക്കറിയാം D7S2 ആണ്. So definitely rhodium and iridium also will have the same electron configuration, no difference at all. ഇനിയിപ്പോൾ അയണോ റുത്തീനിയോ ഓസ്മിയോ ഒക്കെ എന്താണ്, അത് D6S2 ആണ്. മറ്റവരാണെങ്കിൽ D8S2 ആണ്. മൊത്തം ഇവിടെ 8 ഇലക്ട്രോൺ ഉണ്ട്, ഇവിടെ 9 ഉണ്ട്, ഇവിടെ 10 ഉണ്ട്. മനസ്സിലായില്ലേ? ഇപ്പോൾ റോഡിയം 1 എന്ന് പറഞ്ഞാൽ എന്താ, ഇവിടെ 8 ഇലക്ട്രോൺ ആയി. അത് ഇറിഡിയം 1 എന്ന് പറഞ്ഞാൽ 8 ഇലക്ട്രോൺ തന്നെയാണ്. ദിസ് ഇസ് ഇറിഡിയം 1 because it is the same formula minus. ഇതിലുള്ളത് 2 അയോഡൈഡ്, CO. നേരത്തെ കേസിൽ എന്തായിരുന്നു, ഒരു വ്യത്യാസമില്ല. ഇറിഡിയത്തിന് പകരം റോഡിയം ആയിരുന്നു. ഇൻ ദി Monsanto process the metal is rhodium. And see, another point is, നേരത്തെ പറയാൻ വിട്ടുപോയതാണ്. You can see that the best anion found is iodine. Iron, bromide, chloride activity വളരെ കുറവാണ്. No other anion is found to be as effective as iodide. നമുക്കറിയാം എന്തുകൊണ്ട് iodine പകരം bromide, chloride ആയിക്കൂടാതെ. iodine പകരം bromide, chloride ആയാലും ആക്ടിവിറ്റി കുറഞ്ഞു, യാതൊരു സംശയമില്ല. iodine ആണ് best anion both in the Monsanto process as well as in the new process that we are going to see, that is the Cativa process. Okay, and you can see that the catalytic cycle, and if you are familiar with the previous one, it is very easy to write this one because it is very similar. You can see that again it has only 4 species. You can see that it is First you can see that is the oxidative addition of methyl iodide, which in turn is produced from methyl alcohol, which is one of the reactions. Our reaction by reaction with you can see HI. HI will be produced. HI is produced at the end by the hydrolysis of acetyl iodide into acetic acid by a reaction with the water. Water is formed by the reaction between these two. That is H2O. That H2O will be combining with acetyl iodide to form the so the iridium based catalyst first react with the methyl iodide and involves in an oxidative addition reaction, and we can see that the methyl iodide is added. Okay. Now the next step is the removal of a carbon monoxide. Carbon monoxide is also the iodide. An iodide. Iodide you can see that this species is formed, and this undergoes a so this is the other reactant, a carbon monoxide. This carbon monoxide ends here, acts here, and it is converted into IR with a one CO, the second CO, the third CO, that is this CO, then comes a iodide, okay. Now this undergoes a sorry. Iodide, why CO added you can see that iodide is substituted with CO. So the next step is a migratory insertion. Is used the second reactant second reactant added, that is a carbon monoxide. And we can see the product formed here is the acetyl complex with a IR here. We have COCH3, iodide, CO. This product is formed. The 5-coordinate complex is formed, the acetyl complex. The methyl complex is converted to acetyl complex by the migratory insertion. And the next stage, it undergoes the reductive elimination. And here you can see that in the reductive elimination step, the CH3CO and I goes as a CH3COI, which react with water, forming CH3COH. This is and you can see that the product formed is acetic acid. And here you can see if it goes with one iodide, there is one iodide less than this one, and this iodide end is I minus. And this is the same iodide that has left in this stage. After the iodide പോയിട്ടുണ്ട്, iodide ഇവിടുന്ന് തിരിച്ച് സൈക്കിളിലേക്ക്